Okay, on PBS scripting, I don't want to get like too much in the weeds too fast, but it's a script that tells the computer how to wait in line, basically. So what we have is basically a PBS script puts you in line. So let's say there are 1,000 users and all 1,000 want to start a simulation at the same time. So right, that would be very expensive on the system. So what happens is PBS is basically taking a ticket and waiting in line for your turn, essentially. So it's a fair way to do that. It can be, if you have money, you can get higher options. For example, like my research group, we have a computing queue that it gets us higher priority in the waiting line, essentially. All right, so that's something to be aware of. But let me explain to you, basically try to give you a vision of what it looks like. So we are here, you're working at your desk or you're on a laptop or whatever. You use on demand, okay, the portal to open up a web page, which would then open up an ACI terminal, right? We've been doing that already. And from that terminal, we load up Abacus. So there it is. So it's a way to look at another computer. We're on ACI. It's a cluster that sits near in University Park, and we're accessing that. It runs Red Hat Linux. All right. Well, there's another way that we can go about it. When we actually connect to this, what's actually happening is that it's connecting to ACI head nodes. There's like a number of those, right? So there's like 20 or whatever the number there is, and that's what we actually log into. And so if the system senses that there are a lot of users trying to use Abacus CAE, it'll load up 20 on the first processor and then say, oh, time to use another computer because we don't want to make it too slow for these existing 20. So they keep scaling up as many as needed. Okay, and it's used really for pre and post processing, right? So you're not supposed to run computations on it. We have been doing that, but it's not really the polite way to do it. All right, what you really need to do is there's this other cluster that's called ACI B, and that's called the B stands for batch computing. And what happens is they also have head nodes that you log into, so you can actually establish this kind of connection to the head nodes. But then you submit a PBS script on one of these nodes, and it submits that job to a bunch of compute nodes. So there's many more compute nodes than there are head nodes. Head nodes are basically used for managing and visualizing and things like that, where the compute nodes are actually a lot faster and then used for computing. So how do you connect to this? What we're going to do is we're going to show that when we're on the portal, we're going to open up a second terminal and connect to that cluster. So that's the other thing I need to mention, that this is not like the same thing. These are actually two different clusters that we're accessing. They're designed differently. Okay, so we actually connect, we create this terminal and we connect using what's called SSH. It's a Linux command that allows us to do a secure tunnel essentially through the internet. So nobody else can get in that tunnel. So it's a very secure way to communicate with other computers. So we're going to be using SSH to do that. And the command that we're going to be using to do that is SSH space your user ID at submit at aci.ics.psu.edu. This is the host name. You can also, there are variations that you can do here. So for example, you could do SSH space -L space your user ID. Then you don't need the @ symbol. You just put a space and then the host name. This thing here, submit.aci.ics.psu.edu, is called the host name. And it's just basically a name, a written name, letters, that is assigned to an IP address. Okay, and then once we get on ACI B, we'll be able to submit jobs to the open queue with something like this, qsub -a space open space script.pbs. I will show you how to do this as we go there. So now let's jump back to ACI. All right, so here I'm over on ACI. I'm going to actually minimize this Abacus job here. Oops, not that. Okay, and I'm over here in app 6, my ACI or ROR. I'm going to open up a new terminal, File Applications, Terminal, okay, and I'll make this a little bit bigger for you. Okay, so now we're going to log into that other cluster. If I can shrink this a little bit. Okay, so this is how I usually operate. I open one on ACII, and then I'm going to run that command. So I'm going to do SSH space L, my username. Now in this case, you would put your username there, and then submit.aci.ics.psu.edu. Okay, kind of stretched out there, or wrapped. There we go, just like that. And now we can push enter. It's going to ask you for your password. And then you're going to pick which one. I'm going to do a duo push to my cell phone. All right, so now you can see this looks similar. If I do an ls, you have all the same files that you had there before. But one of the things we notice is that this like prompt, what we call the prompt, looks different, right? So on ACII, it's comp-IC, whereas here it's submit-004. So this is the cluster. These are essentially two different clusters, head nodes that we logged into. However, they actually have the same file system, right? So if I do a list on my home directory, that's what I see, and you can see it's the same file. So they're two different clusters, but they're reading from the same file system. It's kind of like if you have a USB external hard drive that you plug into two different computers, you can see the same file system. So if you took two different computers and plugged it to the same US external hard drive, you'd be able to see the same thing, same concept. All right, so now we want to navigate back into our app 6, cd work. Classes, ME461 app 6. Okay, and in there I have a PBS script. Okay, we can visualize that. Notice if we try to do like gedit like we've done before, nothing works. You can't open up visualization or any kind of graphics on this ACI B terminal. You have to go over to ACII and you can do gedit abacus, what's it called, _ app 6 PBS. And you can see here we're going to use, this is kind of like PBS language, we're going to use 2 processors, we're going to use 5 gigabytes of memory. We're going to run for 30 minutes. This is a memory on Abacus memory, I think. And then we're going to load Abacus. We can actually remove this. That's old. So module load Abacus. And then it's going to run, the command to actually run it's here. Abacus job equals job 1, CPUs is equal to 2, and it's interactive. So we can say save to that. What I'll do is I'll probably update this file on Canvas so you don't get any errors, but if you're using this one, you may need to remove that module load. Okay, so all right, so we can close that now. And now we have, you can see here, that job 1 was job1.inp. That's what it's looking for. Where does that come from? Well, over on Abacus, when we did our check, right? What you can do now is do a write input. Okay, that job1.inp already exists, so say okay, that's fine. What you can see is it wrote job1.inp. So this is important. If you named your job something different, I always take the default. But if you named your job something different, you might have to go to that PBS script and change that. Right? You would need to change that right here. So instead of job 1, you might have put, app 6 or something like that. So that's one comment. I'm going to keep mine the same since I just took the defaults. Okay. Then I'm going to go back to ACI B, ACI B, I have the job1.imp there. I had this PBS script that I know is up to date, and now I'm going to submit it. So to do that, you do Q sub. You need to tell it what queue you're entering in. So -A, we're going to use the open queue. The open queue is free. You don't get higher priority, so that's a drawback, but you can run for, I think it's like 36 hours on the open queue, so it's pretty good. All right, so now we're going to submit to the open queue, and we're going to submit that PBS script, that app6 PBS script, and then we're going to push enter. So we're going to submit that, and what you see is it's going to run under the open account, and then here is your job ID. So there are thousands of jobs, well maybe not thousands, let's see. What we can do is do a qstat -u, and then your username, okay? And this tells me I have 2 jobs going. I have one, that's the G desktop, that's basically the portal, okay, because it creates a job when it does that. And then I have this new one that's in the queue. This, if I pull this out and run this again, it'll be easier to see. Okay, so this job here I just submitted for 30 minutes using 2 processors is in the queue right now. Okay, so that's good. You can see all the other jobs that are on there if you just do qstat. Okay, and this plots all the people that are running jobs on this system. You can see lots in line, some are complete, C, and some are running, that's the R. All right, so this is a great way if you have parametric studies to run multiple different jobs at the same time. So for example, here you can see this is probably a parametric study that someone's running with all these different values in them, and they want to see the different results. Those are put on different processors so it doesn't slow down simulation time. So this user is doing a lot of studies today. All right, and our job, we can check it here, and it's still in the queue, so we're still waiting. So what we'll do is we'll wait till that starts. It should go to R, and then it should go to C when complete. So what I'll do is I'm going to pause the video here and then come back when it finishes.